Hello out there, welcome back once again, and we're still on statistics and we're looking at correlations. So this part of our lesson, what we would like to look at is calculation. How do we calculate this correlation? So we know now what is perfect correlation, what is no correlation, what is weak correlation mean. But how do we calculate this? Okay. So let's see how we really actually calculate the correlation coefficient. So we're going to look at calculate the correlation coefficient. So we have a question here. So a cardiologist wants to test the relationship between resting heart rate and the peak heart rate during exercise. Okay. So the heart rate is measured in beats per minute, okay? Then a set of data was generated from 12 study participants after they had a run on a treadmill at 10 kilometers per hour for 10 minutes. Okay, guys? Okay? So that's what we're going to do. Okay. So a set of data is generated from 12 study participants after they had a run on a treadmill at 10 kilometers per hour for 10 minutes. Okay. So what we have here, we have resting heart rate and the peak heart rate. Okay. So resting heart rate is actually, if I'm not doing any exercise or walking, my heart is pumping less blood into the body, so the heart rate becomes lower. The moment I start engaging in an exercise or something of that nature, or moving or exercising, then the heart rate increases. Okay, so the resting heart rate, when I'm resting, kind of relaxed, and peak is when I'm exercising optimally. Okay, so what we have here is that the resting heart rate for first person was 48, and the peak heart rate was 138. Similarly, the last person's resting heart rate was 62, and the peak heart rate was 155. So now, let's look at the first question. What do we have to do here? So the question, given the same data, we have to draw a scatter plot of the data using resting heart rate as the x-axis. So this will be our x, and that will be our y. Okay, remember, our scatter plot is x, then y, and we just put all the coordinates. Okay, let's see what we have to do. So we have to choose a suitable scale. That's very important for the axis. Draw the axis, very important, and plot points. Remember, points, for example, this as a point will be 48 and 138. So this will be x, and that will be y as a point. And we have to do for each and every point, from here all the way to 62 and 155. Let's see what we get. This is what you get if we put all the points. Okay? So we can see that 48 and 138. 48 is somewhere there, 138 is somewhere there. We get that point. So all the points have been done for us, which is the peak heart rate on the y-axis and the resting heart rate on the x-axis. By looking at this, does correlation exist? Yes, I think it exists. Is a correlation negative or positive? I think the correlation is actually positive because you can draw a straight line with a positive gradient. Okay, and I think it's a strong positive correlation. Okay, that's the first question. Now, without using a calculator, find the correlation coefficient, R. And after that, we're going to confirm using a calculator. How do we calculate this correlation coefficient? Okay, we have the data. How do we calculate this correlation coefficient? Well, it's positive correlation and it's strong. Let's see how we do that without using a calculator. So calculating the correlation coefficient, we have to use this formula. Okay, the coefficient correlation is B times, the B is the gradient of that line, the standard deviation of X over the standard deviation of Y. Okay, we'll explore that, what it means. The coefficient is just the gradient, the slope of the line of best fit, the standard deviation for X and the standard deviation for Y. B, estimate the slope, okay, we agree on that. And that sigma X is a standard deviation, and that is a standard deviation for Y also. Okay. Let's see. Then the standard deviation we know is given by this formula, and we know the standard deviation is the average deviation from the mean. Okay. That it's included on your formula sheet as a standard deviation. Okay. And one can actually use the calculator to calculate the standard deviation also. Let's see how we do this. So firstly, what we have to do is to determine, so we're given that we're still using the same table, is to find X bar and Y bar. This is the average for X and the average for Y. Let's see how we do this. So the average for X, meaning we add everything there, are we all together, divided by N. N is 12, so this is the sum of everything, divided by 12. We get that the average resting heart rate is 71, because that's X, remember, and this is Y. And the average for Y, we add everything all the way to there, divided by what? By the total, which is 12, which is N. So this is adding everything, divided by 12, then we get 154.83. So that's the peak heart rate. Are we all together? That's what we did. So we have the average for X and the average for Y. Then from there, this is what we have. The resting heart rate, we can see that. And this table, we have the peak heart rate. Another way. What I have to do is to find X minus the mean squared. So it's just X minus the average. Then I square that. So that will be 48 minus the average, then square that. So we do for everything. And for Y also, and we know that the average is 71. And the average for Y is 154.83. So we do the same thing for Y. It's Y, which is 138 minus 71, then we square that. So this is what we get if we complete our table. Are we together? So how do we get this number? 48 minus 71 squared. That's what we get. How do we get that number? Is we use the Y, 138 minus the average, we square the number. That's what we get. Then we complete our table. Then sigma, this sign, just add everything. We add everything. This is what we get. We just add everything. Similarly also, here we add that. This is what we get. We add the square deviation also. And this is our total. And we do similarly here. And this is our total. Let's see what we can do with this. So what we're going to do now is, we know this, the standard deviation, okay? We know this, which is, where is this? There, we'll transfer that. And the sample size, which was 12. We just substitute everything. We get, I think, about plus minus 3.26. We do this similarly with Y, the square deviation there, which is that value, we put it there, we divide it by 12, and that's the value we get. And the B value is 1.96. Then what we do here is the standard deviation for X, over the standard deviation for y, and we multiply the two. That's what we get, which is 0.87. That's the correlation, which is actually strong positive correlation. Okay, without using a calculator. Usually, I would use my calculator to calculate correlation, unless you don't have your calculator, or they say without using a calculator. It's just a long and tedious calculation. Okay. So with using a calculator, some of you might have a sharp calculator, and some of you might have Cashier. Using a sharp calculator, you have to enter your x and y. So this is our x and this is our y into your calculator in stats mode, plus statistics mode. So in a sharp calculator, this is the process you follow to calculate correlation. Okay? I will demonstrate this using a Cashier calculator. How do you calculate the correlation coefficient? Okay. So with a Cashier calculator, let's see. If you go back with a Cashier calculator, let's see, we have to enter our data. Also, this is our x, and this is our y. Okay? So I've already have imported our data. We can see that 48, 138, which is x, okay? And we can see that 56, 135, okay? So how do you do that on a Cashier calculator? You can see that is on Cashier calculator, press Shift, then Stats, then 5, 3, then equal. Okay, are we together? Are we all together? If you get your stats table, you put all the data. So that's where we are. So I have my table, I put all my data, my x and y. After putting my data, I'm going to say AC. From there, I'll say Shift 1. 1 means the stats. Then from there, I have option 1 to 7. I can see the first option says type, 2 says data. If I put 2, it will take me back to my data set, what I've inserted. So I can just say Shift 1 again, 7, select regression. Select 7. I can see A, B, C, and X with a copy, Y with a copy. What I want is 3, the correlation, and I'm just going to put 3 there, and I'm going to say equal. Then actually it gives me, so there should be 58, let's fix that. That should be 48, that's equal. So what I have to do is actually AC, Shift 1, then select 7, then select 3. Then equal, that's my correlation coefficient, which is approximately 0.87, which is exactly the same, I think, with what we got without using a calculator, which is a strong positive correlation. Let's see. Which is what we have. That's the correlation. Okay, so what can you conclude regarding the relationship between the resting heart rate after exercise? Are we all together? What can you conclude? There is a strong relationship, association between the two. Strong, positive correlation. Okay, fantastic. So now, what are we going to do? Is there is a strong, positive, linear relationship between the resting heart rate and peak heart rate during exercise. This means that the higher your resting heart rate, the higher your peak heart rate during exercise. Okay, likely to be. Are we together? Are we together? And usually, actually, with the heart rate, I mean, the more fitter you are and the more you exercise continuously, then your resting heart rate is lower and actually your peak heart rate. Okay, you can try that if you have any of the heart rate measuring device. Okay, watch if you exercise, something of that nature. Okay, are we all together? Good. Okay, so let's look at now at our summary, what we've looked at, guys, now. So we have looked at the scatter plot, and we said, what is a scatter plot? Our scatter plot is drawing all the points, the x and y, the independent and dependent variable. We put all the points. That's how we get our scatter plot. The correlation coefficient. The correlation coefficient, we said, is between -1 and 1, where 1 is strong correlation, -1, strong negative correlation, and 0 is no correlation. Okay. And we can calculate the correlation coefficient using a calculator. Okay. You put your table and you calculate your correlation coefficient. And we've looked at the mean and the standard deviation. And the mean and standard deviation came in, how do we calculate the correlation coefficient without using a calculator? Okay, we're together, guys. Okay. I hope you enjoyed out there. Okay, and I really encourage you to continuously work hard and push. And the only way to do your mathematics is if you continuously work. Don't wait for the big test to come for you to start working. You do your maths, even 30 minutes per day, an hour per day, every day. If you're continuous and you're on that and you're consistent, that's the only thing that's going to make you successful in studying anything. Okay. We hope to see you soon, and remember to work continuously. Cheers out there.